June 6, 1944, 5:47 a.m. Tokyo, Imperial Japanese Navy Headquarters. Commander Ryunosuke Kusaka reviewed the intelligence report that had just arrived via submarine from occupied France. American and British forces had launched the largest amphibious invasion in history. Operation Overlord, landing 156,000 men on French beaches in a single day using thousands of specialized landing craft. As chief analyst for Japanese amphibious warfare planning, Kusaka understood the implications immediately. If Americans could land armies on defended beaches in Europe, they could land armies on defended beaches in the Pacific. But one detail in the report caught his attention and triggered professional skepticism. The primary landing craft, designated LCVP by Americans, was described as a flat-bottomed wooden boat, 36 feet long, powered by a single diesel engine, with a ramp bow that dropped to disgorge 36 men or a vehicle. No armor protection, no sophisticated landing gear, just a simple, shallow draft boat that could approach beaches, drop a ramp, and withdraw. "This cannot be the main assault craft," Kusaka muttered to his aide. "This is riverboat design, not military landing craft. Flat-bottom boats cannot handle ocean waves. Wooden construction is vulnerable to any defensive fire. Single engine is single point of failure, and front-loading ramp exposes troops to direct fire when lowered. This design violates every principle of military naval architecture." Kusaka had spent years studying amphibious warfare. Japan had conducted amphibious operations across Pacific and Asian coastlines. Japanese military has developed specialized landing craft, purpose-built steel vessels with multiple engines, protective armor, and side ramps that provided some cover when disembarking. The American design intelligence described looked primitive by comparison. Either American intelligence officers were exaggerating the role of these simple boats, or Americans were conducting the world's largest amphibious invasion using equipment Japanese engineers would reject as inadequate. Note in the file that American reliance on these crude landing craft represents opportunity, Kusaka wrote in his assessment. Their landing craft are vulnerable. They lack armor protection. They cannot operate in rough seas. They expose troops to defensive fire. When Americans attempt major amphibious operations against Japanese-held territories, these design deficiencies will prove catastrophic. Our beach defenses need only target these boats during approach and landing phases. What Commander Kusaka didn't know, what Japanese military intelligence had completely failed to understand, was that he'd just dismissed the Higgins boat, officially designated LCVP landing craft vehicle personnel. The simple wooden boat that would deliver over 2 million American troops onto hostile beaches across the Pacific, that would enable every American amphibious assault from Guadalcanal to Okinawa, and that Dwight Eisenhower would later call the boat that won the war. Within months, Japanese defenders at Tarawa, Saipan, and dozens of Pacific islands would watch in horror as hundreds of these primitive riverboats delivered waves of American Marines onto their beaches faster than defensive fire could stop them. Within 2 years, Japanese military would be desperately trying to copy the design they dismissed as inadequate. This is the story of how Andrew Higgins' simple wooden boat revolutionized amphibious warfare, how Japanese engineering prejudice blinded them to its effectiveness, and how Japanese engineers' dismissal turned to desperate imitation as Higgins' boats delivered armies that their sophisticated landing craft could never match. To understand why Japanese engineers dismissed the Higgins boat, you need to understand Japanese amphibious warfare doctrine and the landing craft they developed based on that doctrine. Japanese amphibious warfare doctrine and the landing craft they developed based on that doctrine. Japanese military had extensive amphibious operations experience, the invasion of China, the conquest of Southeast Asia, the capture of Pacific Islands, all required amphibious landings. Japanese engineers had developed landing craft reflecting Japanese naval architecture principles. Japanese landing craft philosophy, steel construction. Japanese landing craft were built with steel hulls, providing durability and some protection against small arms fire. Steel was proper naval material, wood was for civilian boats. Multiple engines. Japanese designs used 2 or more engines for redundancy. Single engine failure wouldn't strand craft. This reflected Japanese emphasis on reliability through duplication. Side ramps. Japanese landing craft featured side-loading ramps, reasoning that disembarking troops from sides provided better cover than front-loading, where defensive fire could sweep entire ramp. Deep draft. Japanese craft used conventional naval hull designs with keels and deeper drafts, providing better seakeeping in rough water, but requiring troops to wade through deeper water when beaching. The result was landing craft that looked like proper naval vessels, steel construction, multiple engines, naval architecture principles. They were expensive to build, requiring skilled shipyard labor and scarce steel. Production was slow, limiting numbers available. Japanese Daihatsu-class landing craft specifications. Length, 46 to 52 feet. Construction, steel hull, steel deck. Engines, 2 diesel engines, later models. Capacity, 70 to 120 troops or light vehicles. Speed, 7 to 8 knots loaded. Cost high, required shipyard construction. Production time, 4 to 6 weeks per craft. Armor, light steel plate, 6 to 8 millimeters. Vulnerability, magnetic mines, heavier weapons. These crafts served Japanese forces adequately during early war operations when opposition was light. But they had critical limitations Japanese doctrine hadn't addressed. They were expensive, slow to produce, required deep water approaches, and couldn't be manufactured in quantities needed for large-scale operations. Lieutenant Commander Toshikazu Ome, Japanese naval officer who participated in numerous amphibious operations, explained the Japanese perspective in post-war interviews. We built landing craft using proper naval architecture principles. Steel hulls like warships, multiple engines for reliability, side loading for tactical advantage. We considered these obviously superior to simple boats. When we learned Americans were using wooden flat-bottomed boats with front ramps, we assumed Americans lacked proper naval engineering expertise. We were confident our landing craft were better designed. We didn't understand that American design optimized for different priorities: mass, production, and simplicity. That would prove more important than our sophisticated engineering. Andrew Jackson Higgins was a New Orleans boat builder with no formal naval architecture training. He built shallow draft boats for the Louisiana oil industry. Boats that needed to navigate swamps, bayous, and shallow coastal waters. His designs emphasized practicality over elegance. When the U.S. military began searching for landing craft designs in 1938 to 1940, they had specific requirements. Shallow draft to approach beaches closely. Ability to retract from beaches after landing. Fast production using non-shipyard facilities. Low cost for mass production. Simple enough that minimally trained crews could operate them. Durable enough for repeated use in rough conditions. Higgins's Eureka boat design, developed for Louisiana marshlands, met these requirements better than any purpose-built military design. The military tested it, improved it, and adopted it as LCVP, landing craft, vehicle, personnel. The Higgins boat. Higgins boat LCVP specifications. Length 36 feet 3 inches. Beam 10 feet 10 inches. Draft 3 feet forward, loaded 3 feet 6 inches aft. Construction, plywood hull, wooden frame. Engine, single diesel, 225 horsepower. Speed, 12 knots loaded, 15 knots unloaded. Capacity, 36 troops or 8,000 pounds cargo vehicle. Crew 3, coxswain, engineer, bowman. Armor, none on hull. -inch steel on coxswain station and gunnel. Cost $5,000 to $7,000 per boat. Production time 2 weeks, later reduced to 1 week. Ramp, bow-mounted steel, manually operated. The design seemed primitive compared to Japanese steel landing craft, but the Higgins boat had advantages Japanese engineers didn't recognize. Flat bottom, allowed beaching in as little as 3 feet of water. Troops could disembark with minimal wading. Japanese craft required 6 to 8 feet, meaning longer, dangerous wade through surf. Wooden construction. Could be built by furniture factories, boat builders, and facilities without shipyard expertise. Didn't require strategic steel. Could be repaired quickly using carpenter skills. Single engine, simplified maintenance, reduced mechanical complexity, lowered costs in practice. Engine reliability was good enough that redundancy wasn't needed. Front ramp. Allowed rapid vehicle unloading. Troops could exit in organized waves directly onto the beach. Despite exposure concern, speed of unloading compensated for vulnerability. Shallow draft. Could approach closer to the beach than any other landing craft, reducing time troops spent in the deadly surf zone. Mass production. Simple design enabled production of 20,000 plus boats during war. Japanese produced perhaps 3,000 Daihatsu craft total. But most importantly, the Higgins boat worked. It could handle ocean swells better than flat-bottom design suggested. The wooden hull proved surprisingly durable. The single engine was reliable, and the front ramp, despite theoretical vulnerability, proved practical in actual combat. Japanese forces first encountered Higgins boats during the Guadalcanal campaign in August 1942. The initial assessment confirmed Japanese prejudices about American landing craft inadequacy. At Guadalcanal, initial landings occurred with minimal opposition. Japanese defenders observed American landing craft from concealed positions but didn't engage heavily during the landing phase. Post-landing reports from Japanese observers noted the wooden boats, the front-loading ramps, and the lack of armor. Colonel Kiyono Ichiki, commander of Japanese forces that would attack American positions, wrote in his final dispatch before his death, "American forces landed using primitive wooden boats that exposed troops to fire during disembarkation. The boats lack armor, use single engines, and appear vulnerable to any defensive fire. Their reliance on these crude craft suggests American naval engineering is inferior to ours. When we attack, we should target these boats during supply runs, destroying them easily and cutting American supply lines." This confidence that Higgins boats were vulnerable would prove catastrophically wrong. At Guadalcanal and subsequent operations, Higgins boats proved remarkably difficult to sink. Small arms fire mostly bounced off or penetrated without causing catastrophic damage. The wooden hulls could absorb considerable punishment. The diesel engines were reliable and hard to disable with rifle-caliber fire. And the boats could be repaired quickly using basic carpentry. But the real revelation for Japanese forces was the operational capability Higgins boats provided. They could make multiple trips daily, shuttling troops and supplies continuously, operate in weather conditions that grounded other landing craft, beach and retract rapidly, minimizing exposure time, be repaired quickly when damaged, returning to service in hours, operate with minimal maintenance and limited spare parts. The logistical advantage these capabilities provided was enormous. American forces could sustain continuous reinforcement and supply operations, using hundreds of Higgins boats cycling continuously between ships and beaches. Japanese forces attempting similar operations with their slower, more complex Daihatsu craft couldn't match the tempo. The Battle of Tarawa, November 1943, provided the most visible and brutal demonstration of Higgins boat capabilities and limitations under extreme defensive fire. Tarawa's BTO Island was defended by 4,500 Japanese troops behind fortifications that included concrete bunkers, beach obstacles, and killing zones designed specifically to destroy landing craft. Japanese Commander Rear Admiral Keiji Shibasaki had boasted, "1 million men cannot take Tarawa in 100 years." The American assault used Higgins boats to transport Marines from ships to the reef line, where LVT landing vehicle tracked. Amphibious tractors would carry them across the reef to the beach, but many LVTs were destroyed or disabled, forcing Higgins boats to deliver Marines directly to the reef edge, 700 yards from shore. Japanese defenders watched as hundreds of Higgins boats approached, each carrying 36 Marines. Japanese artillery, machine guns, and rifles targeted the boats during approach. Some boats were hit and destroyed, but most survived to discharge their troops at the reef edge. What Japanese defenders expected, that wooden boats would be easily destroyed by defensive fire, didn't happen at scale they anticipated. Individual boats were hit and sunk, but the sheer numbers overwhelmed defensive fire. Hundreds of boats approaching in waves meant Japanese gunners couldn't target all of them. Most boats delivered their troops and withdrew despite heavy fire. The brutal part was the 700-yard wade from reef to shore. Marines disembarking from Higgins boats at the reef had to wade through chest-deep water under withering fire. Over 1,000 Marines were killed or wounded during this approach, many shot while wading from Higgins boats through the lagoon. Japanese observers interpreted this as validation that front-loading ramps and wooden construction were fatal flaws. Commander Susumu Kawaguchi, observing from a bunker, wrote, "American wooden landing boats proved as vulnerable as predicted. Many were destroyed during approach. Troops disembarking from front ramps were exposed to direct fire, suffering massive casualties. If Americans had used a proper landing craft with side-loading and armor protection, they would have suffered fewer losses." This confirms superiority of Japanese landing craft design, but Kawaguchi's assessment missed the critical point. Despite the carnage, the Higgins boats had delivered an entire Marine division onto a heavily defended island in less than a day. Tarawa fell within 76 hours. American casualties were horrific, 1,000 dead, 2,000 wounded, but they'd accomplished something Japanese doctrine said required weeks and resulted in failure. The Higgins boats had worked, not perfectly, not without terrible cost. But they delivered an army onto a defended beach and sustained operations until the island was captured. Japanese landing craft couldn't have delivered troops at the same rate or sustained the same operational tempo. The invasion of Saipan, June 1944, demonstrated Higgins boat capabilities at maximum scale against prepared Japanese defenses. Saipan's beaches were defended by 30,000 Japanese troops with artillery, machine guns, and beach obstacles. Japanese defensive plans assumed American landing craft would approach slowly, present vulnerable targets, and be destroyed in sufficient numbers to disrupt landings. What happened instead shocked Japanese defenders. The American assault employed 700-plus Higgins boats in coordinated waves, delivering 8,000 Marines in the first 20 minutes. The boats approached in organized formations, disgorged troops rapidly, and withdrew to cycle back for more loads. Japanese artillery targeted the boats but couldn't achieve sufficient hit rates to disrupt operations. Individual boats were destroyed, perhaps 30 to 40 lost to enemy fire on D-Day, but the sheer numbers meant 660-plus boats completed their missions. They delivered 2 full Marine divisions onto Saipan beaches in the first hours, establishing beachheads faster than Japanese defenders could coordinate counterattacks. Major Yoshida, Japanese artillery officer on Saipan, survived the battle and provided testimony. June 15, 1944, American landing craft approached in hundreds. My artillery battery targeted them but couldn't achieve sufficient destruction. We'd hit 1 boat, and 3 more would land before we could reload. The boats were wooden and looked fragile, but most survived our fire. They delivered troops so rapidly that within 2 hours, thousands of Americans were ashore. Our defensive fire killed many troops, but it couldn't stop the landing. The sheer number of boats overwhelmed our defenses. If Americans had fewer boats, we could have destroyed enough to stop landing. But they had so many that destroying some didn't matter. The operational mathematics were devastating to Japanese defense. Each Higgins boat could make 4 to 6 trips on D-Day, cycling between ships and beach. 700 boats making 5 trips each delivered 126,000 troops. 700 times 5 times 36 equals 126,000. Even with significant losses, the volume was overwhelming. Japanese Daihatsu craft, had they been defending, couldn't have matched this tempo. Fewer in number, slower in speed, longer to load and unload, Japanese craft would have delivered perhaps 20 to 30% the volume of troops in the same time frame. This disparity, American ability to deliver armies rapidly using simple boats versus Japanese inability to match that tempo with sophisticated craft, became decisive advantage across Pacific campaigns. What made Higgins boats strategically decisive wasn't just design, it was the production capacity American industry brought to manufacturing them. Andrew Higgins' New Orleans plant became the largest private employer in Louisiana, running 24-hour shifts, producing landing craft at rates that Japanese intelligence refused to believe, even when provided accurate numbers. Higgins Industries production statistics. Peak employment, 20,000 workers. Production rate, peak, 700 boats per month. Total LCVPs produced, 23,358. Total Higgins designed craft, all types, 92,098. Production facilities, 8 plants, New Orleans and elsewhere. Construction time, 1 to 2 weeks per boat. Cost per boat, $5,000 to $7,000. These numbers meant American forces could lose landing craft in combat and have them replaced within weeks. Boats damaged in operations could be written off rather than repaired. Replacement costs were low enough that extensive repairs weren't economically justified. Japanese production, by contrast, was constrained by steel shortages, shipyard capacity limits, and skilled labor requirements. Each Daihatsu craft required 4 to 6 weeks to build in specialized shipyard facilities. Japan produced roughly 3,000 total during war, less than Higgins Industries produced in 3 months at peak. This production disparity created operational flexibility Americans exploited, but Japanese couldn't match. American amphibious commanders could plan operations knowing thousands of landing craft were available. Japanese commanders planned operations knowing landing craft were scarce, precious resources that couldn't be risked casually. The strategic implications were profound. America could conduct multiple simultaneous amphibious operations across Pacific. Japan could barely defend, with landing craft reserves insufficient for counter-landing operations. The Okinawa invasion, April 1945, was the ultimate test of Higgins boat capabilities, the largest amphibious operation in the Pacific War, involving 1,500-plus landing craft delivering 183,000 troops against defended beaches. Japanese defenders had studied American amphibious tactics for 3 years. They understood Higgins' boat capabilities and had designed defenses specifically to counter them. But understanding American methods didn't provide tools to stop them. The Okinawa landings employed every lesson learned from previous operations. Higgins' boats approached in precisely coordinated waves. Naval gunfire and airstrikes suppressed beach defenses during the approach. The boats delivered troops with mechanical efficiency wave after wave, establishing overwhelming force ashore before Japanese defenders could respond effectively. Lieutenant General Mitsuru Ushijima, commanding the Japanese 32nd Army defending Okinawa, wrote in his journal, April 1st, 1945, American landings today demonstrated their amphibious warfare superiority. Their wooden landing boats, which our engineers dismissed as primitive, delivered an army onto our beaches in hours. We killed many Americans during landing, but we couldn't prevent landing itself. They have too many boats, too much firepower, too much coordination. Our defensive fires are like throwing stones at an avalanche. Individual stones hit individual targets, but the avalanche continues regardless. American amphibious capability is a weapon we have no counter for. The operational tempo sustained by Higgins boats at Okinawa was staggering. Over 430,000 troops were landed on Okinawa during the campaign, delivered by landing craft shuttling continuously between ships and beaches, day after day, week after week, maintaining supply flows that enabled sustained operations. Japanese forces attempting similar logistics using their limited landing craft capacity couldn't match this sustainability. The few Japanese attempts at counter-landing operations failed quickly because the Japanese couldn't deliver forces at rates needed to overcome American defensive fire. By 1944, Japanese military recognized that Higgins' boat design was superior for mass amphibious operations. They attempted to copy it. The attempts failed, revealing why American success wasn't simply about design, but about industrial capacity to mass produce. Japanese engineers studied captured Higgins boats and created similar designs, flat-bottomed wooden craft with bow ramps. But production attempts foundered on multiple obstacles. Materials shortages. Japan lacked plywood production capacity equivalent to American. Japanese plywood was lower quality, limiting hull strength. Steel for ramps and fittings was allocated to weapons production. Engine availability. American boats used gray marine diesel engines produced by tens of thousands. Japanese lacked equivalent engine production capacity. Attempts to substitute Japanese engines required redesign. Production facilities. American boats were built in furniture factories, boat yards, and improvised facilities. Japanese production remained concentrated in military shipyards already overloaded with warship construction. Skilled labor. American furniture workers could transition to boat building using familiar woodworking techniques. Japanese workers needed specialized training for naval construction standards. The result was Japanese producing perhaps 200 to 300 Higgins-style boats versus American production of 20,000 plus. The design advantage Japanese finally recognized came too late to replicate at scale needed. Commander Toshikazu Ome, tasked with improving Japanese amphibious capabilities, wrote in 1944, "We now understand American wooden landing craft design is superior to our steel designs for mass operations. Simplicity enables mass production. Wooden construction uses non-strategic materials. Shallow draft enables close beach approaches. We are attempting to produce similar craft, but cannot match American production rates. Understanding the design doesn't help when we lack industrial capacity to mass produce it. This is frustrating, knowing solution but unable to implement it. Behind the statistics were American sailors and Marines whose lives depended on Higgins boats functioning under fire. Coxswain's operating Higgins boats were exposed on small platforms behind minimal armor plate. They steered boats into defensive fire, maintaining course while bullets ricocheted off hulls and ramps. Many were killed or wounded during landing operations. Seaman First Class Raymond Davis operated a Higgins boat at Tarawa. He survived, but 12 of the 36 Marines he delivered were killed during the wade from reef to shore. His account recorded in 1984. I drove that boat through machine gun fire, artillery fire, and hell itself. Marines trusted me to get them close enough to shore to give them a fighting chance. Half my passengers died in the water after I dropped the ramp. I had to withdraw, pick up another load, and go back. You don't forget delivering men to their deaths. But the boat worked. It got me there. It got me back. It survived hits that should have sunk it. Andrew Higgins built a tough little boat that saved my life while I was delivering Marines into hell. The Marines delivered by Higgins Boats faced the most dangerous part: the transition from boat to beach. The ramp drop was the moment of maximum vulnerability. Troops surged forward into waist-deep water while enemy fire swept the ramp. Many died in those first seconds. Private First Class Eugene Sledge, Marine veteran of Peleliu and Okinawa, wrote in his memoir, "The Higgins boat delivered us as close to the beach as possible. When the ramp dropped, we ran into the water and tried to reach cover before Japanese machine guns cut us down. The boat got us there. What happened next depended on luck, training, and whether Japanese defenders had a clear line of fire. The boat's job was delivering us within reach of the beach. It did that job under fire, repeatedly without fail. That's all we asked of it." After the war, military analysts from multiple nations studied American amphibious operations and consistently concluded that Higgins boat had been enabling technology for Pacific victory. General Dwight Eisenhower famously stated, "Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different." Japanese military officers studying American operations reached similar conclusions from a different perspective. Vice Admiral Shigeru Fukudomi, former chief of the operations section at Imperial Japanese Navy headquarters, wrote in his post-war memoir, "American success in Pacific was determined by amphibious capability we couldn't match. Their simple wooden landing boats, which we dismissed as inferior, proved superior for mass operations requiring thousands of craft. We built sophisticated steel landing craft in limited numbers. Americans built simple wooden craft in overwhelming numbers. In amphibious warfare, numbers matter more than sophistication. We learned this too late to adapt. The contrast between Japanese and American amphibious capabilities was stark. American amphibious capacity, landing craft available, 1945, 60,000 plus, all types. LCVPs available, 23,000 plus. Troops deliverable in single operation, 200,000 plus. Sustainable operations, multiple simultaneous invasions. Japanese amphibious capacity, landing craft available, 1945, 2,000 to 3,000, all types. Troops deliverable in single operation, 10,000 to 15,000. Sustainable operations, single operation with difficulty. This 20-to-1 advantage in landing craft numbers translated directly to operational capability. Americans could invade anywhere at any time with overwhelming force. Japanese could barely conduct defensive counter-landing operations. June 1994, New Orleans, Louisiana. 55th anniversary of D-Day and Pacific War operations. The National World War II Museum, then called the D-Day Museum, hosted a commemoration attended by American and Japanese veterans. Among them was former Higgins boat coxswain Raymond Davis, 71, and former Japanese naval officer Toshikazu Omai, 79. Through translators, they discussed the landing craft that had shaped the Pacific War. Omai spoke first. In 1942, when I first learned Americans were using wooden boats with front ramps for amphibious operations, I was confident our steel landing craft were superior. Our boats had armor, multiple engines, sophisticated design. American boats looked primitive, but I was wrong. American boats worked better because simplicity enabled mass production. By war's end, Americans had 20,000 boats. We had 3,000. You won through industrial capacity to build simple things in overwhelming numbers. Former coxswain Davis responded, "The Higgins boat wasn't fancy. It was plywood and an engine and a ramp. But it worked. It could handle 6-foot seas. It could beach in shallow water. It could be repaired by any carpenter. And most importantly, we had enough of them to deliver armies anywhere we needed. That's what won, not sophisticated engineering, but simple design produced in quantities that overwhelmed defenses. A young naval architect in the audience asked, "Could Japan have mass-produced Higgins-style boats if they'd recognized the design's value earlier?" Ome answered honestly, "Theoretically, yes. Practically, number. American design required plywood production capacity we lacked, engines we couldn't manufacture in sufficient numbers, and industrial flexibility to convert civilian factories to military production. We understood the design by 1943 but couldn't replicate the industrial system that made it possible. That was our fundamental problem. Not lack of engineering knowledge, but lack of industrial capacity." The ceremony included display of a restored Higgins boat that had participated in multiple Pacific operations. Both American and Japanese veterans touched the wooden hull, reflecting on how this simple boat had carried war across the Pacific Ocean. Former Marine Eugene Sledge, speaking at the ceremony, delivered a summary assessment. "That simple wooden boat delivered me and thousands of other Marines onto Japanese-held beaches. It wasn't comfortable. It wasn't safe. It wasn't sophisticated, but it worked. It got us there. And when we needed resupply or evacuation, it came back and got us out." Andrew Higgins designed a boat that could be built by thousands, operated by anyone with basic boat handling skills, and survived abuse that would sink more sophisticated craft. That combination, simple, tough, producible in mass quantities, won the Pacific War as surely as any weapon. The Higgins boat's influence extended far beyond World War II. The principles it embodied, simple design for mass production, functionality over sophistication, adequate performance in overwhelming numbers, shaped modern military procurement philosophy. Modern amphibious warfare still uses descendants of Higgins's design philosophy. Landing craft remains simple, producible in large numbers, designed for adequate performance rather than perfect performance. Final statistics. Higgins boat LCVP production and impact. Total LCVPs produced 23,358. Total Higgins design craft, all types, 92,098. Cost per boat, $5,000 to $7,000. Production time, 1 to 2 weeks. Troops delivered in Pacific Theater, 2+ million. Troops delivered in European Theater, 1.4+ million. Percentage of Allied amphibious operations using LCVPS 90% plus. Japanese landing craft comparison. Total Daihatsu craft produced approximately 3,000. Cost per boat 3 to 4 times higher than LCVP. Production time 4 to 6 weeks. Troops delivered capacity 10% of American capacity. Operational impact. Amphibious invasions conducted by U.S. in Pacific, 27 major operations. Average troops landed per operation, 50,000 to 200,000. Landing craft lost in combat, all types, approximately 2,500. Replacement time days to weeks. Japanese counter-landing attempts, 3, all failed. Post-war recognition. Eisenhower quote, "The boat that won the war." Museums with Higgins boats, 15+. Restored operational Higgins boats, 6. Historical impact ranking among top 10 most important World War II technologies. The story of the Higgins boat is ultimately about how simple solutions produced in overwhelming quantities can defeat sophisticated solutions produced in limited numbers, and how engineering prejudice can blind the military to effective innovations. Japanese engineers dismissed the Higgins boat in 1942 because it violated every principle of proper naval architecture they'd been taught. It was wooden, not steel. It had 1 engine, not 2. It used front loading, not side loading. It looked primitive, not sophisticated. Commander Kusaka had reviewed intelligence reports and concluded American reliance on these boats was a weakness to exploit. He'd been confident that Japanese steel landing craft with sophisticated design would prove superior in combat. He'd been completely wrong. The Higgins boat proved superior not because its engineering was more sophisticated, but because its simplicity enabled mass production that sophisticated designs couldn't match. American factories produced 23,000 boats in the time Japanese shipyards produced 3,000 craft. That 7-to-1 advantage meant American forces could conduct amphibious operations at scales Japanese couldn't imagine. Every major Pacific invasion, Guadalcanal, Tarawa, Saipan, Iwo Jima, Okinawa, relied on Higgins boats delivering troops onto beaches. Every operation saw hundreds of boats shuttling between ships and shores, delivering wave after wave of troops faster than defenders could kill them. Japanese defenders could hit individual boats, they could kill troops during landings. But they couldn't stop the landings because the sheer number of boats overwhelmed defensive fire. Destroy one boat and 10 more landed. Kill 36 Marines from one boat and another 360 landed from 10 more boats. The mathematics were inexorable. Simple design times, mass production times, operational persistence. An overwhelming advantage that sophisticated design in limited quantities couldn't counter. Japanese engineers who dismissed the Higgins boat as primitive learned too late that primitive design produced in overwhelming numbers beats sophisticated design produced in inadequate quantities. That lesson came as Higgins boats delivered American armies onto Japanese-held beaches faster than Japanese defenses could stop them. By 1945, the Japanese military understood the Higgins boat had been a critical American advantage. But understanding came too late for Japan to replicate both the design and the industrial capacity needed to mass produce it. The dismissal had been a mistake born from engineering prejudice. The consequence was strategic defeat in the amphibious warfare domain, where Japan had once claimed superiority. Andrew Higgins had designed a simple wooden boat using principles he'd learned building craft for Louisiana swamps. That boat carried over 3 million American soldiers, sailors, and Marines onto hostile beaches on 2 continents. Japanese engineers dismissed it as inadequate until it delivered armies on their beaches and proved that adequate design produced in overwhelming numbers wins wars, that perfect design in limited quantities cannot. The wooden boat with the front ramp proved tougher, more effective, and more strategically important than sophisticated steelcraft because simplicity enabled scale that sophistication prevented.